Hello and welcome. Today we'll be discussing one of the most popular and foundation topics in mathematics, which is indices. I'm so excited to be with you here today, and I'm happy that you are devoting your time and energy and resources to learn, and I assure you that you're not wasting your time. So let's dive into one of the most interesting topics. But first, remember that this mathematics series is only one out of the numerous series that we are going to be having. So after maths, you still have physics, you have chemistry, you have so many other subjects coming up. So if our physics videos are not here yet, the physics videos will be uploaded soon, and the chemistry video also will be here. So make sure you turn on the notification or subscription button, then share the videos and make your comments. Also tell us where you are watching from and the topics you want us to treat. Mention them in the comment section so that we'll treat them. Actually, sometimes we'll be going live, we'll be having live classes so that we'll treat the exact topics and attend to your questions. So if you have any questions, if you encounter problems, drop them in the comment section or use our email address to email us your questions so that we'll attend to them. So without wasting much of our time, let's dive in. So the topic is indices. Okay, so as we all know, indices is the plural form of index. So when we have index, which we equally call the exponent, which we can also call the power. So this is a scientific shorthand or mathematical shorthand of a short method of summarizing a rather long expression. Like if I supposed to multiply a letter A, which represents a number, if I'm supposed to multiply letter A by itself up to like 3 times, for instance, mathematicians were able to find a way to summarize this multiplication and just make it to be written in a simple form, like A to power 3. In this case, A to power 3 here, showing that I'm using A to multiply itself numerous times up to 3 times. So this 3 here is the power. It is the index, it is the exponent, it is the number of counts. Now, I want to correct an impression. Some people usually take powers to be multiples. Like if they have A squared, someone can write it, or some people used to take it as 2 times A. But this is exactly wrong. It is a very wrong notation. A squared is not 2 times A. This 2 here is a count. It is the number of times A will multiply itself. We take note of that. So it is very important that you recognize that this power, this number that is hanging, is representing the number of times the multiplication will occur. It is just like a counter. So we keep that in mind as we dive into this. So this beautiful expression that we have just generated, we are going to use it and make other interesting relationships. We are going to establish so many other relationships, so many other interesting and fascinating relationships concerning multiplying numbers with power. So let's watch out and see how this is done. It is going to be very exciting. So what we now have is what we call the laws of indices. But before that, I want to also emphasize that as I have this expression A to power 3, this A here is called the base of the expression, while this 3 is the power or the index, right? So we keep note of that, so that once you see these expressions, or once we make reference to the base, you know what we mean. Once we make reference to the power, you know what we mean. Always make sure that you raise the power, you keep it hanging as a superscript. Some people make mistakes of not differentiating between the base and the power when they are expressing it. So you raise it a little bit high so that it shows that this is a power, not a factor. Right? Okay, so let's get to the laws of indices. There are many laws of indices, and for the want of time, we are not going to write all the laws of indices here. But trust me, I'm going to show you the very few laws that will be very useful for this application for all our exams like WAEC, Jamb, and NECO, GCE, all those exams. The laws that we are going to use here will be very, very sufficient and enough for us to solve any problem we encounter in all these exams. So, and we are not going to overwhelm you with multiple and numerous laws. I'm just going to select few of them that are relevant to us, and then you see how we use them. So let's get started already. So the laws of indices, we start from very simple expression. Look at this. If we have a to power 3 multiplying a to power 2, for instance, what do you think it is going to be? By expression, if you understand what indices means, you will know that a to power 3 means a times a times a. This is for a to power 3, right? So I'll leave this for a to power 3. Then times the next expression is a squared, which is a times a. So that is what I have. So if I remove this my brackets, I'll have this to be the same thing as a times a times a times a times a. So this is for this first part, this is for the second part, this last two is for the second part. So when I join them, I have that, I'll count the number of a's to write them in index form. So this is going to be a raised to power 1, 2, 3, 4, 5. So this whole thing sums up to a raised to power 5, right? So you can now see that I have a to power 3 times a to power 2, and at the end of the day, I have my answer to be a to power 5. So it is safe to say, and has been generally proven in mathematics, that once I have, so you can see that 3 plus 2 gave me 5. So mathematically it has been proven that once I have a represents the base, any base at all, raised to a power m. M is any number at all, any real number. So a to power this m times a to power n. So this can be 3, it can be any number times a to power another number. Now what I need to do is to simply sum the power. So I'll have a raised to power m plus n. So that is just a law that we are going to keep hold on to. So once we have a to power m times a to power n, it means we can sum them up and have them as a to power m plus n, just as we have just seen here. So that's one of the laws that we are going to keep hold on to. So that's the first law. We'll find the second one. Just similarly, just as we have done this, we are going to see the second law. So if I have a to power 5 divided by a to power 2, for instance, a to power 5 divided by a to power 2, I know that a to power 5 is the same thing as a times a times a times a. 1, 2, 3, 4 times a. This is a to power 5. All upon the second part, that is divided by, that's all upon the second part is a to power 2, which I'll have as a times a, that's a to power 2, right? And then what will I do? I'll cancel. A can divide a for a, and at the end of the day, I'm left with just a and a, which is just a times a times a, which is a to power 3, right? So I'll be left with a to power 3. So it means that if without doing this, I will see that a to power 5 minus 2, a to power 5 minus 2 is the same as a to power 3. So what I've just established here is that a to power 5 divided by a to power 3 is the same thing as a to power 5 minus 2, which is the same thing as a to power 3, as we have seen here. So what this has shown us is that anytime we have a to power m divided by a to power n, that we should go ahead and say that this is a to power m minus n. Just subtract them. So once we have division between them, the bases are the same. Division between them, all we need to do is to subtract the powers and we are okay. So that's what we have seen from this one. Another law of indices of interest will be the zero power. So when we have a to power 0, what should it be? Okay, a to power 0, it is, the value is 1. Hold on. Hold on. Let's know how. This is not a joke. Let's just know how this is true. Okay, let's try it out and see. 8 to power 0 let's take, for instance, we are having 8 to power 3 divided by 8 to power 3, right? Now, we'll solve it on two parts. Now, by the law of indices, the very previous law which we have just established, this is going to be 8 to power 3 minus 3 because it's division, so we have to subtract the powers, right? And that is going to be 8 to power 0, right? So 8 to power 3 divided by 8 to power 3 is going to be 8 to power 3 minus 3, which is 8 to power 0, right? So that's what we get using the law that we just established. Or let's solve it using what we know about indices. 8 to power 3 is written as a times a times a divided by, this is another 8 to power 3, which is a times a. So I can cancel this for this for this, and this for this. At the end of the day, once I cancel all this, I'll be left with 1 because what I have on top is 1 and what I have below is 1. So 1 upon 1 is still the same as 1. So all we are saying is that on this side, we solved it this way and we got 1, and we solved it here and we are getting 8 to power 0. So what we are saying is that 8 to power 0 is written as 8 to power, is written as 1. So what this law implies is that anything, it can represent any number, any whole number, any fraction, whatever it is, real number or any complex number. When you have a number to power 0, just know that it is 1. So 8 to power 0 is 1. Take note of this, and you will make very use of this when you start solving problems. You see how handy it will be. So 8 to power 0 is 1. Okay, similarly, let's get to this part. 8 to power minus 1 is equal to 1 upon 8. So how true is that? Let's take 8 to power minus 1. Let's know what it will be. By law of indices, let's have something like 8 to power 2 divided by 8 to power 3. For instance, 8 to power 2 divided by 8 to power 3. So by law of indices, this is 8 to power 2 minus 3, and that is 8 to power minus 1, right? But then, let's express them, let's expand. So in that expansion, we are going to have 8 to power 2 is the same thing as a times a divided by 8 to power 3 is a times a, and that is this a for this for this, and we'll be left with what we have on top is 1 and what we have below is a. So you can now see that 8 to power minus 1 is the same thing as 1 upon a. So we solved it using the law of indices and we arrived here. We solved it by expansion and we arrived here. So you can see that 8 to power minus 1 is 1 upon a. In general, we can write the next expression. So without needing to prove that, we'll have that number 5, 8 to power minus n is the same thing as 1 upon a to power n. So once you see negative power, it means 1 upon. So 8 to power minus n is the same thing as 1 upon a to power n. You can always prove that. You can do it with various numbers. We can say 8 to power 2 divided by 8 to power 5, for instance, and then we'll see that this is going to be 8 to power 2 is a times a, and the 8 to power 5 is a times a times a times a times a. So we are going to have 1, 2, 3, 4, 5 a's here. So a for a for a, and then what we have on top will now be 1 all upon what you have below is a times a times a, that is 3a's. So we are having 8 to power 3. So we can now see that, and then by law of indices, this is going to be 8 to power 2 minus 5, which is the same thing as 8 to power 2 minus 5 is minus 3. So this is 8 to power minus 3 is 1 upon 8 to power 3. I hope we understand. So anytime we have a to the power minus negative power, we just have it to be 1 upon a. Are we together? Okay, now let's get another law. For time's sake, let us hurry and get the rest of the laws. So we have another part. We say, well, we have a to the power m to the power n. You can see in this case, a to the power m and then still to the power n is the same thing as a to the power m times n. That is, it's okay to write it as a to the power m n. That is m multiplying n. So if I have a to the power m multiplying raised to the power n, then it is same as a to the power mn. Also, I have that a b to the power m, two bases to the same power, is the same as a to the power m b to the power m. Remember, all these laws that we are stating are reversible. Like we can get them here. We can get questions that look this way and return them to this way, or we can get a question that looks this way and return it to this way, depending on the nature of the question and the application or what we want from the question. So we can always interchange them. Once we have this, we can replace it with this. Once we have this, we can replace it with this, depending on application. It applies to all the laws that we have just stated. And the next one we can talk about will now be about fractions, fractional base. Also, we can have a upon b to the power m. For instance, a upon b to the power m is the same thing as a to the power m upon b to the power m. So if I have them all to the same power, it's okay, it is safe. It is very mathematically correct to write this as this. I can get this and return it to this way. So a upon b all to the same power is same as a to that power upon b to that power. You will see the application in a short while. Okay, another one is about fractional indices. This is where majority of the students usually have problems. Look at this. If I have a to the power 1 upon 2, this is number 9, a to the power 1 upon 2, this is going to be, I have a to the power a fraction. It is the same thing as a square root of a. In fact, in general, if we have a to the power 1 upon m, a to the power 1 upon m, it is exactly the same thing as this denominator becomes the root. So it is the nth root. The nth root of a. Remember, this is nth root. It is different from m root. If I write this is m root a, but here is nth root of a. So for you to get that, if I have 2 root a, it is 2 times the square root of a. But if I have square root, this is the square root of a. But for square roots, we don't usually put the 2. We omit it and we know that it's square root. It is when we have a number that is greater than 2, that's when we usually put it. So I want you to make sure that you write it well. So a to the power 1 upon m is certain as the mth root of a. And then let's get to the next one, the 10th one. We'll have a to the power m upon n. A to the power m upon n. In this case, okay, let me use n as the power and m as the let me use this as numerator and this as denominator. Okay, so if I have a to the power n upon m, any of them can serve. I just want to know why I had to switch this. Okay, a to the power n upon m, this power or this numerator will now serve as the power, and the denominator will serve as the root. always know that denominator is the root at all times. Denominator is the root. So as I have 1 upon m here, m is the root. Here, m is the root. Like whatever that is below is the root. So this is the same thing as nth root of a to power n. So if I have 8 power n upon m, it is the nth root of a to the power n. In fact, this particular law is very similar to this guy. It is just the same thing as this, just that the power here is 1. What we have on top is 1. So once we have a fraction for indices, the fraction, how you treat the fraction is that the numerator is the power. So I want to, I know why I'm emphasizing this. I want to use different markers to write this. So this is the power, and here is the root. It is important that you know how to sort them. What you have on top is the power, and what you have below is the root. So just make sure you are aware of these powers and roots, fractional indices, all these fractions, and when you are dividing, when you are multiplying, when you are having multiples of powers. So make sure you take note of this, because sometimes students get confused when they start seeing questions that look like this. In fact, in our next class, we begin to apply all these. So write them down, jot them, and make sure be rest assured that you are going to enjoy using these laws to solve problems. So in the next video, we are going to see the problem. We'll start solving problems on all these. So let's just use these 10 laws. Trust me, these 10 laws will be enough. They will be very much sufficient for us to solve every problem that we are going to encounter for our WAEC, our Jamb, and both all the external examples, UTME, any university or undergraduate exams. We are going to this will help you. It will be able to help you navigate and find your way through. So if there are any topics you would like us to treat, please mention them in the comment section, and feel free to ask your questions. If you have further questions, you can send them to our email. We'll answer them, or you can put them down on the comment section. Share the videos, like and subscribe to the channel so that you'll be updated. You know when we update the new videos, and you'll be notified. Once we update our videos, you will have a notification. Always know that our chemistry classes, our physics classes, these science classes are all coming up. So you check for them. The series are still there. So thank you for watching.